computer. All right, so for the people watching this video, this is for you. I normally wouldn't do this, but how dare you have a holiday? Just kidding, don't sue me. Today's lesson is going to be about something called the rate of change. I know it says average rate of change, but literally just rate of change. And I made a little speech in the classroom saying the rate of change is a special way of saying slope. Okay. You mind if I just go through my quick spiel again? Just really quick, I'll do it. Okay, so the idea is this: if I had a graph and in grade 9, you started learning about straight lines, right? And whether it's direct or partial variation, all they did was check, if I move to the right by 1, how high do I go up? If I move to the right by 1, how high do I go up? If I move to the right by 1, how high do I go up? Right? And depending on what context that is, you talk about it in a story. Like if this was distance driven by a car, let's say, after 1 second, I drove 1 meter, 1 second, 1 meter, 1 second, 1 meter. The slope then would discuss how quickly I'm moving. It would be speed. If I were to talk about, let's say, money, right? And we have this line here. After 1 day, I made $10. After 1 day, I made $10. After 1 day, I made $10. What is this slope discussing? What is it talking about? Well, how quickly you make money. The rate of change, how quickly your money is changing, how quickly the distance is changing is what we mean by rate of change. So this class, we're going to talk about the rate of change as slope, which is change in the dependent variable over as the independent variable changes. Right? Does that look familiar? I hope so, because it's basically saying y2 minus y1 over x2 minus x1. Rate of change is the slope of a secant, I'll get to that in a second, between 2 positions in time. And we don't care about it as direct or partial variation. Okay? Now, what is a secant? Anytime we have a curve, a line that joins 2 points in a curve is called the secant. It's just a math word. You might have seen this again. You might have been introduced to this in grade 9. In geometry, or maybe it's grade 10. In geometry, maybe there's a circle and you learned about things like circumcenter, centroid, and all that stuff, sort of. One of the words that you learned was a line that connects 2 points on a circle, but does not go through the center, is called a secant. Same thing here. Right? Why do we look at a secant? Well, I want to know how quickly something changed from 1 point to another. As opposed to trying to figure out how quickly a curve changes, we simply get the average change between those 2 points by calculating the slope between those 2 points. That's it. And so we call that average rate of change. In short, when you want to calculate the average rate of change, it is the slope between 2 points. Ta-da! End of chapter 1.5. Yes, Yusuf? Good point. Good point. But again, what is the goal? I just want to see, on average, if I took a trip from Toronto, let's say, the malls at Niagara Falls, right? The outlet malls. What is the average speed during that trip? Sometimes you want to figure that out, right?
Yeah.
Sometimes. Yeah. So sometimes you want to, sometimes you are interested in the average. And so this is how we do it, right? So when we get to more, more detailed things and we want to know exactly how fast we're going, then we'll get to 1.6, right? So bear with me. Any questions so far before we start using this in question context? Okay, so let's move on then. Clearing this. A new antibacterial spray is tested on bacterial culture. The table shows the population P. So this is the population of bacteria right? T minutes after the spray is applied. T obviously is time. So 0 minutes, 1 minute, 2 minutes, 3 minutes, all the way to 7. This graph is not supposed to be, perfectly marked, but I think you get the point, and that's 7. Population starts at 800, and I'm assuming that is 37, so it goes all the way down to 0. Okay. Determine the average rate of change of the number of bacteria over the entire time period shown in the table below. The average rate of change, AROC, I want to know how quickly the population drops. That's another fancy way of saying, what's the slope? So over the entire time period means from 0 seconds to 7 seconds, what is my rate of change? What do you need for slope? Very quickly, Leslie? Yeah. So this point is 737 because I have the data on the chart. And away we go. So I'll write, instead of slope, because there's meaning to it now, average rate of change is equal to so that would be question, Zach, or
Yeah, it's a quick question. So for every question, we always say, like, the smallest x and the largest x to it. Like, we want to find, like,
oh no, the question asked for the entire time period, and I chose the first point and the last point.
oh, okay. So it'll specify what.
It will specify. It must.
Yeah.
Otherwise, that's not fair. Okay. It'll be yeah. Interpret the value of this rate. So delta y over delta x. So 37 is the y value, 7 is the x value. Minus minus. 800 is the y value, 0 is the x value, and so that equals negative 763 over 7. Oh, mental math. Oh, thank you, grade 9. Okay. Okay, so that would be something, but I need to interpret it. Giving me a negative 109 would be correct in grade 9. But at this point in time, there is a meaning behind that number. What is this slope telling you about? Go ahead. Yeah. So I'm going to say minus 100 bacteria per minute. Absolutely. So again, it's very simple. The formula is from grade 9, but does it make sense in this context? Right? The slope is causing something to drop over a certain period of time. Compare the AROC of the number of bacteria in the first 3 minutes and in the last 3 minutes. So again, I'm forcing you to do the slope formula. This time, I'm going to erase this. You can draw the secants if you want, but I'm asking you to calculate the rate of change for the first 3 minutes, and then calculate the rate of change between the last 3 minutes. So if you want to use a different color, you can, or if you don't even want to bother and you want to do it mentally, you can. So that's 1, 2, 3. The secant is here. It's not the best. And then I'll use blue. The secant from minute 4 to minute 7 is there. If I were to extend it, so I'm basically looking at the slope of this line versus the slope of that line. I need some space, so I'm going to move this up. Okay. Perfect. So I'm going to do AROC, and I don't know how you like to do it. I'm just going to do from 0 to 3. just to remind me that this is the slope of the first 3 minutes. I've got 737 over 3 minus 800 over 0, which is going to be negative 63 over 3, which is negative 9. Oh, 21. Embarrassing. This is being recorded too. Four to 7 is equal to 650. How about I just do the small one first? 37 over 7 minus 652 over 4. Oof. That's 52, right? 627, 5, 5, 1, 1, 5. Yeah. Which is negative 205. If I made a mistake, please let me know. But yeah, it's the slope, which makes sense, right? They slowly start dying off, and then the antibacterial, like the poison for them, it becomes more and more effective because it starts to spread and they're absorbing. It takes a little bit of time for the antibacterial to work. But once it finally gets into these bacteria, they start dying off at a faster rate. So it sort of makes sense. From a visual perspective, the slope is very shallow. The red line is very shallow, and then the blue line is very steep. That's another way you can talk about it. It all sort of comes together. Any questions? No? Okay, maybe you want to digest it a little bit. So examine the table of values right here. Examine this, examine the graph, and the average rate of change. In other words, I guess just A, because this is clear. But if you were to just get the average rate of change, which of these three helps you see that the rate of change is changing? I'll say it one more time. Which one of these three helps you see that the average rate of change is changing? Or rather, sorry, I'll say it one more time. Which one of these three, the table, the graph, and this, which one of these three helps show you that the average rate of change is changing? No. Pick out average. Which one of these three shows you that the rate of change is changing? Oh my gosh. Just rate of change is changing. Oh, Declan? The graph does, absolutely. Right? It's clear that it's getting steeper and steeper. What else? Same people. Good? Yeah, you can tell that the decreasing increments are getting bigger and bigger. Absolutely. Part A. Does the average rate of change from 0 to 7, that one number, tell you whether rate of change is getting bigger and bigger? No. So as Yusuf was saying, it's inaccurate. There may be value in calculating the calculating the rate of change at different parts of the graph to make or to talk about it differently, to have more detail, to get the bigger picture of the situation. Which makes sense. I don't think you need to be convinced of that. And that brings us to chapter 1.6. That is, how do you calculate the instantaneous rate of change? Okay. How do you calculate the rate of change exactly at 0, exactly at 1, exactly at 2, exactly at 3, 4, 5, 6, 7? Is that an idea or a question? Yeah, so we're going to get to the tangent. The video stops here. That's the end of chapter 1.5. And it's essentially the end of the sheet as well, I believe. There's no back question. Okay. I'm going to stop us in just a second and get us ready for chapter 1.6.